I love physics because it's a model that we have for the way that the world works. But what's fun once you have a model is that you get to probe other aspects of the model that you might not observe in nature. Hi, I'm Maria Okounkova. I'm a second-year graduate student in the physics department at Caltech. I work in the TAPIR group and I'm funded by the Dominic Orr Graduate Fellowship. TAPIR stands for Theoretical Astrophysics Including Relativity. I work mainly in the relativity bit, and I spend my days working in the field of numerical relativity, which is solving Einstein's equations on the computer. I had a fellowship coming into Caltech my first year, and then it was extended to my second year. And this essentially means that I have my own source of funding and I'm not tied to any professor, although I do have advisors and professors who I work with. This is something that I really enjoy because I had a curiosity about this, and I, have so many experts around me that I'm able to approach them and ask them to work with me on these problems. A lot of these postdocs and professors are role models for me. Also, having a fellowship means that I have money to travel, which means that I can attend more conferences than usual, and I'm sort of excited to, forge collaborations with these people and, just really get immersed in the field. And I think having money to travel and go to conferences is very important for that. And this is nice because I know for a fact that I love to teach, but I didn't know what sort of line of research I ultimately wanted to do. So without having that extra time constraint of teaching, I was able to explore all these possibilities. What I like is sort of probing gravity at the very strong levels, when everything is strongly coupled, everything is just very dynamic and interacting, and there are very fast speeds and very heavy masses. And so what I really like are black holes. Within sort of the mathematical theory of general relativity, there are certain questions about, can you form a black hole? Will you form a black hole? And it's very difficult to try to do this with pencil and paper because the equations are so complicated and we only know of, a few solutions to the theory. So instead, I use supercomputers to try to solve the equations numerically. So I've spent a lot of the year developing this code to simulate my particular system, which is essentially a special configuration of particles. These particles move along space and time, but because they're massive, they also influence the space-time. So you can see that there's this strong coupling relation there, and this is why I really like numerical relativity, because you explore areas of the parameter space that you have no hope of solving with pen and paper. You have your own astrophysical system and you get to, do whatever you want with it and you get to play with it.